Hi, I'm Aditi from Data's Good, and I thank you for joining us today. At Data's Good, we have trained thousands of students in our live classes and helped them make successful data science careers. I welcome you to this full course of data visualization. In this data visualization complete course, we learn what is data visualization, importance of data visualization, basics, advanced, animated and interactive visualizations, and miscellaneous charts. So before we begin, make sure you have subscribed to our channel, and also don't forget to hit the bell icon to stay updated with the latest videos coming from Data's Good YouTube channel. So let's begin. Data visualization is a graphical representation of information and data in a graph, chart, or other visual formats. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in data. We find that visualization is one of the most powerful techniques when it comes to analyzing data and, more importantly, understanding data. And this is because we as species have been reading numbers in earnest for the last 50 years, maybe 100 years also. We've been reading text for no more than 600 years, and we've been listening to stories only for the last 10,000 years, ever since the language was created. But we as a species have been looking visually at things for millions of years, for as long as eyes have existed. And that is what is hardwired to brain. We understand things much quicker visually than we do any other way. This is both a blessing and a curse. It's a blessing because we have a bypassing most conscious data ingestion methods and directly provide insight to the brain. But at the same time, we have well-known biases, and it's pretty easy to fool the eye, as you would know from the variety of optical illusions that you may have seen. Having said that, every attempt should and is being made to use data visualization as a way of communicating data effectively to people. So let's talk about some examples of data visualization that convey information at large quantity, at scale, effectively. So what data visualization does, among other things, is increase data density, the amount of visual misinformation that you can convey to a much higher level, because we are seeing this as pixels, as imagery, rather than numbers. Our ability to interpret them also grows. So we can see more things and therefore find more patterns from this. Another thing that data visualization does is help us understand the flow and structure in an intuitive way. Now we know that why data visualization is important. We look at the benefits of good data visualization. Since our eyes can capture the colors and patterns, therefore we can quickly identify the red portion from blue, square from the circle. Our culture is visual, including everything from art and advertisements to TV and movies. So data visualization is another technique of visual art that grabs our interest and keeps our main focus on the message captured with the help of eyes. Whenever we visualize a chart, we quickly identify the trends and outliers present in the data set. The basic uses of the data visualization technique are: data visualization is a powerful technique to explore the data with presentable and interpretable results. In the data mining process, it acts as a primary step in the pre-processing portion. It supports the data cleaning process by finding incorrect data and corrupted or missing values. It also helps to construct and select variables, which means we have to determine which variable to include and discard in the analysis. In the process of data reduction, it also plays a crucial role while combining the categories. There are three types of analysis for data visualization. These are univariate analysis, bivariate analysis, and multivariate analysis. So let's start with univariate analysis. Let's first understand what is univariate analysis and how it can be useful. Univariate analysis is a type of data visualization where we visualize only a single variable at a time. Univariate analysis helps us to analyze the distribution of the variables present in the data so that we can perform further analysis. Now, we've gained a lot of knowledge about univariate analysis. Let's also understand how to perform univariate analysis in Python. To do that, first of all, we will have to open our Jupyter notebook. Then we have to upload the data set on which we are going to work. We are going to use the employee data set, which you can easily download from the resources section. First of all, we will have to import the pandas library. If you've not installed the pandas library yet, then you can open your command prompt and type pip install pandas. After that, we will have to import the Seaborn library in our Jupyter notebook, which will help us to perform data visualizations. Similarly, if you've not installed the Seaborn library yet, then you can open your command prompt and install it using the command pip install Seaborn. After you're done with importing of libraries, you can read the data set that you're going to work with. Now, we already know that we are going to work with the employee data set. So let's read this data set using the read CSV function. After that, we can use the head function to check the top 5 rows of the data set. We can also check the shape and columns present in the data set. Finally, the environment is set up and we are ready. First of all, we'll perform univariate analysis on a numerical variable to understand how to perform univariate analysis on numerical variables. We are going to perform the univariate analysis on the age column. To do that, we will be using the distplot function from the Seaborn library. After we execute the program, we can see a chart where the distribution of age is shown. Not only that, there's tons of information hidden in this single chart. Now, let's also check how to perform univariate analysis on categorical data. Generally, we use countplot for that. This time, we want to check the distribution for the business travel column. After you execute the program, you can see that the chart has some bars representing the count for each of the categories present in the business travel column. Now you would have understood how these univariate analysis helps us in understanding the distribution of the features present in the data. Our next topic is bivariate analysis. Bivariate analysis is a simultaneous analysis of two variables. It explores the concept of the relationship between two variables, whether there exists an association and the strength of this association, or whether there are differences between two variables and the significance of these differences. We are again going to work with the same employee data set. After importing the pandas and Seaborn libraries and reading the data set, there are two types of bivariate analysis: categorical versus numerical, numerical versus numerical. So let's start with categorical versus numerical analysis. We are going to plot the department and monthly income so that we can understand the average monthly income for all employees working in different departments of the same organization. This can help us in performing comparative analysis among different variables present in the data. Now, let's execute this program and check the result. We can now easily understand that the employees working in the sales department have a better average salary compared to other two departments, whereas the employees working in human resources have a big black line indicating that the average salary of HR department has huge deviation. That means the employees in the HR department have huge differences in their salary. Moving on to the next, we have continuous versus continuous bivariate analysis. In general, we perform plot two continuous variables using a scatter plot available in the Seaborn library. In this case, we are going to check the relationship between the age and the monthly income of the employees. After executing this program, you will be able to see a beautiful scatter plot which displays the relation between age and income of the employees working in the same organization. Now, one clear thing that we can notice from this chart is that the employees who have lesser age, such as 20 to 25, get less salary. Isn't it cool that we can find so many insights and build our instincts based on that? No more guessing when you perform data visualization. Now, we are going to learn about multivariate analysis. As multivariate analysis means to involve multiple variables at the same time to find correlations between them. In technical terms, multivariate data analysis is a set of statistical models that examine patterns in multidimensional data by considering at once several data variables. It can also be termed as an expansion of bivariate data analysis, which considers only two variables in its models. So let's begin. First of all, let's import the Pandas and Seaborn libraries. After that, we'll read the employee data set, which we are going to use for performing multivariate analysis. Now, first of all, we are going to use the heat map function available in the Seaborn library to check the correlation between all the columns present in the data set. But before using the heat map, let's understand what's a heat map and how to understand the output produced by a heat map. A heat map is a data visualization technique that shows the magnitude of a phenomenon as color in two dimensions. The values of correlation can vary from -1 to 1, where -1 means strong negative relation and +1 means strong positive relation. Now, to make a heat map, we are importing the Matplotlib library also, so that we can increase the size of the plot using the rcparams attribute. In the heat map function, we are specifying the color map as Wistia. But if you want to specify any other color palette, then you can specify that also. After that, we are specifying ANOT is equal to true, which means that we also want to see the values of correlation between two variables. And finally, we specify format as 0.1f, which means we want to see the correlation values with only one decimal place. Now, after executing this program, we can take a closer look at the heat map and we can see that very few columns are highly correlated to other columns in the data set. Some of the columns having high correlation are monthly income and job level, performance rating and percent salary hike, total working years and job level, total working years and monthly income, years in current role and years at company, years with current manager and years in current role. So, if there are two columns in a data set which are highly correlated, that means these two columns are highly related to each other and highly similar to each other. Now, let's plot a bar plot where we'll include an extra variable. In this case, the department column will be plotted in the x-axis. The monthly income column will be plotted in the y-axis, and the attrition column will be plotted as a third variable in the chart. After executing this program, you can see the chart. It helps us check the two variables dependency on each with a third variable involved. Now we can understand that how many employees get attrited and do not get attrited in each of the department. We can see that most of the employees in the HR department are not going to get attrited or not going to leave the organization. Similarly, you can add these extra variables in these kind of bivariate charts such as box plots, swarm plots, violin plots, etc. to gather more information. So this was the first part of our data visualization course. Moving to the next part, that is advanced visualizations. There are many advanced visualization concepts and we will be discussing them one by one. So the first is scatter plots. Scatter plots are very popular as they are used in almost every data science project. Scatter plots can be used for outlier detection, understanding the relationship between two continuous variables, and understanding the patterns, etc. So let's get started. First of all, we will import the pandas, Seaborn, and the Plotly Express library. Plotly Express is a new library for us. So if you haven't installed the Plotly Express library yet, you can open your command prompt and type pip install Plotly Express. You can now see that the Plotly Express has been installed successfully. Now let's come back to Jupyter Notebook and import the data set from the Plotly Express library. If you do not know, Plotly Express provides so many data sets so that we can try out all the functions available in the Plotly Express. In this, we are importing the iris data set and we are checking the top 5 rows of this data set using the head function. You can see that there are a total 6 columns which consist of sepal length, sepal width, petal length, petal width, species, and species ID. Now, let's get started and understand why we should use Plotly. To understand that, first let's plot the scatter plot using the Seaborn library. Now let's use the Plotly Express library to plot the same scatter plot where the sepal width is in x-axis, sepal length is in y-axis, and the species column is used to color these points into 3 categories. That is Virginica, versicolor, and setosa. Let's talk about the advantages of Plotly Express library now. First, when you hover the data, you get the information about that data points, making it efficient to check the values. Second, you can drill out and drill up the values. Let's drill out the setosa values from the plot. You can see that setosa is no more visible in the plot. That's so cool. If you want, you can bring it back too. Third, you can add an extra horizontal and vertical margins to analyze the distribution of the data separately. Like you can see from the plot that we are able to check the distribution of sepal length using the violin plot and distribution of sepal width using the box plot. And the most attractive advantage is that you can plot the trend lines also, which will help you to understand the overall pattern of different target classes from the plot. Next one is color scales. We'll talk about color scales and how these color scales can be used in charts for better understanding the insights present in the data. We have so many color scales available in Python, which can be used for data visualization. Visit this website to check different color scales that can be used. Color scales can be used to identify the data points based on a certain value. Let's understand the usage of color scales now by looking at some examples. First of all, we'll import pandas and plotly.express, and then we'll import the data set that we will use for visualization. In this case, we are using the TIPS dataset, which has 7 columns, namely total bill, tip, sex, smoker, day, time, and size. Let's plot a scatter plot between total bill and tip. You can see that every data point is colored with the same color. But what if we want to color these data points based on the size of the tip? Now we just have to specify one extra parameter. That is, color is equal to size. This chart looks much more informative compared to the previous one because here the data points are colored according to a color scale. We have so many different types of color scales, and one of them is viridis. Let's try it out. Hooray! You can see that the color scale is changed and it looks different. Now we'll talk about line charts, area charts, and bar charts. So let's know a little about these charts. A line chart or line plot or line graph or curve chart is a type of chart which displays information as a series of data points called markers connected by straight line segments. Then we have area charts. An area chart or area graph displays graphically quantitative data. It's based on the line chart. The area between axis and line are commonly emphasized with colors, textures, and hatchings. And at last we have bar charts. A bar chart or bar graph is a chart or graph that presents categorical data with rectangular bars with heights or lengths proportional to the values that they represent. The bars can be plotted vertically or horizontally. So as we've got enough knowledge about these charts, let's get started. First of all, we will import the Pandas, Seaborn, and Plotly Express libraries. And after that, we will import the Gapminder dataset. Using the head function, we can see that there are 8 columns, which consist of country, continent, year, life expectancy, population, GDP per capita, ISO alpha, and ISO num. First, let's try to plot a simple line plot between year and life expectancy using the Seaborn library. We can notice from the plot that we are getting one line with a standard deviation denoted by the shaded region around the line plot. But when we use the Plotly Express library, we are getting a line for each record, which is very difficult to analyze and understand the insights in the chart. But let me tell you that it can be useful if we add an extra variable to color these lines. So let's add a continent column in the chart to color the lines. Now we can see that this line plot is much more informative than the previous one. So you can decide which kind of line plot is required for which scenario, and likewise select the required library to plot your line plots. There is one more important feature in the line plots provided by Plotly Express. That is the shape feature, which allows us to change the shape of the line. By default, the shape of the line is in SP-line shape, but we can change it to HV and VH. And you could also notice the change after changing the line shape to HV or VH. Now let's talk about area charts in Plotly Express. You can see it's very easy to analyze the area chart in Plotly Express, as you can drill out the categories as and when required for focused analysis. Now let's come to bar charts. Let's plot a bar chart between the continents and the respective population. You can see that it's a little different from the Seaborn's bar chart, but still it is good to use. Now, let's add an extra variable, that is the smoker column, in the color parameter. You can notice that there's an extra parameter called bar mode. In this case, we are using the grouped bar charts. Let's also take a look at the stacked bar charts. We can use these charts for multiple purposes. And now we are going to learn about the facet grids. Do you guys know what facet grids are? If not, I'll tell you. Facet grids, also known as trellis plots or small multiples, are figures made up of multiple subplots, which have the same set of axes, where each subplot shows a subset of the data. Facet grids sound very interesting. Let's explore how facet grids can be helpful for us for analyzing the data. First of all, we'll import pandas and Plotly Express, and then import the data set that we are going to use for exploring the facet grids. We are using the tips dataset here. So let's plot a grouped bar chart first, where we have sex in the x-axis, total bill in the y-axis, and smoker in the group. We can see from the plot that we can understand the total bill spent by men and women in smoking and non-smoking categories. But if you want to understand the same thing in terms of a day and time, then we might have to add faceting to our chart. Thanks to Plotly for providing this feature. So let's add the day column in the facet call and time column in the facet row. Now we can see an amazing chart which shows us the results for each pattern of day and time, such as Thursday lunch, Thursday dinner, Friday lunch, Friday dinner, etc. This is super helpful as we can now understand the data in multiple layers. We can perform faceting for any chart. Let's see an example of faceting scatter charts now, where we used the tip column instead of sex column to plot the scatter chart. That's great. So this was about facet grids, and we learn about statistical charts now. A statistical graph or chart is defined as the pictorial representation of statistical data in graphical form. The statistical graphs are used to represent a set of data to make it easier to understand and interpret statistical information. In this lesson, we are going to discuss the histograms, the strip plots, the box plot, and the violin plots. So let's know a little about these charts too. Histograms. It's a graphical display of data using bars of different heights. It's similar to a bar chart, but a histogram groups number into ranges. The height of each bar shows how many fall into each range. Strip plots. A strip plot is a graphical data analysis technique for summarizing a univariate data set. Strip plot is simply a plot of the sorted response values along one axis. Box plots. A box plot is a standardized way of displaying the distribution of data based on a 5-number summary. Minimum, first quartile Q1, median, third quartile Q3, and maximum. It can tell us about your outliers and what their values are. And at last, violin plots. A violin plot is a method of plotting numeric data. It's similar to a box plot with the addition of a rotated kernel density plot on each side. Violin plots are similar to box plots, except that they also show the probability density of the data at different values, usually smoothed by kernel density estimator. Now, as we have understood about these charts, let's get into the Jupyter Notebook and implement them using Plotly Express. First, we will import pandas and Plotly Express, and then we'll import the tips data set to explore these statistical charts. So let's get started. Firstly, we'll plot a histogram for the total bill and tip. From the chart, we can see the distribution of both these numerical variables. Now, let's plot a strip plot between the total bill and time, keeping the orientation horizontal. We can easily understand the distribution of these variables by looking at the chart. Now, let's add an extra variable, smoker column, in the color parameter. We can see from the plot, it's more informative now. Now let's move on to the box plots. We can see that the box plot is plotted between days and total bill. Similarly, we can add an extra variable smoker in the box plot, also like we did earlier with strip plot. And similarly, we can plot a violin chart using the extra variable in the color parameter as shown in the figure. But there is an advantage of using violin plots in Plotly Express, that we can plot the box plot and the strip plot at the same time with violin plots. For that, we have to specify box is equal to true and points is equal to all. And you can see that now our violin plot is also showing a box plot inside and strip plot beside it. So this was it. Now moving on to our next topic, polar charts. Before that, let us know what polar charts are. Polar chart is a common variation of circular graphs. In polar charts, a series is represented by a closed curve that connects points in the polar coordinate system. Each data point is determined by the distance from the pole, the radial coordinate, and the angle from the fixed direction, the angular coordinate. Polar charts are generally used when we use cyclic variables. Cyclic variables are those variables which repeat itself after a certain period of time, such as months, January, February to December, and then again January, February. Similarly, there are so many things which keep on repeating, and therefore we use polar charts so that we can understand the cyclic patterns better. Now let's get started and explore polar charts. So first of all, we'll import the Pandas and Plotly Express library. After that, we'll import the wind dataset. Using the head function, we can see that there are only 3 columns in the dataset, that are direction, strength, and frequency. So first, let's use a scatter polar chart between the direction and frequency. This chart looks good. Now, add the strength parameter also to this chart to make it more informative. Similarly, we have line polar charts, which we can make using the line polar function. Also, we have bar polar charts, which we can make using the bar polar function. Now, it's completely up to you which of these charts is best for your analysis. And now, we're going to discuss subplots. So let's know a little about subplots now. A subplot helps us to divide the plot into n number of plots. Using subplot, we can visualize multiple plots at the same time. It has 3 arguments. The first one is the number of columns. The second one is the number of rows. And the third one is the position in the chart. Now let's get started with subplots in Matplotlib and Plotly. It is recommended that you use the subplot from Matplotlib library as it's easy to use. So first of all, we'll import the Pandas and Plotly Express library. We will import the iris dataset here, which we are already familiar with. Before making a subplot using Matplotlib library, we have to increase the size of the plot using the rcparams function so that all the plots in a subplot are easily readable. After that, we have to specify the parameters. And as we have specified that we need 2 rows and 2 columns, we will get 4 plots. So let's plot scatter plots using the columns of iris data in these 4 positions of the plot. We can see It's looking great. Neat and clean, right? Now also explore the subplots provided by Plotly. Remember, it is Plotly and not Plotly Express. So you have to first install the Plotly library so that you can make subplots using Plotly. We will import graph objects and make subplots from Plotly. In Plotly also, we have 3 parameters where we have to specify the number of rows and columns required and then the starting cell. Now, using the add trace function, we can plot anything inside. And it's done. Here's the next concept on 3D charts now. 3D chart simply means a chart which is having 3 dimensions. That is x-axis, y-axis and z-axis. It can be useful when we have to understand the relationship between 3 continuous variables. So let's get started with 3D charts. First, we'll import the pandas and Plotly Express libraries. Then we will import the iris dataset. Now let's get started. Plotly Express provides us very easy way to plot 3D charts. So let's try to plot the sepal length and sepal width and the petal width in the 3D chart. From the chart itself, it looks difficult to analyze the result. And now let's add the species column in the color category. Now it seems very easy to understand this plot. But there's more. We can also specify different symbols to different categories by specifying the species column to symbol. At this time, the chart looks gorgeous. It's now much easier to understand and analyze the insights from these 3D charts. Now we'll discuss the Waffle Charts. A Waffle chart shows progress towards a target or a completion percentage. There's a grid of small cells of which colored cells represent the data. A chart can consist of one category or several categories. Multiple waffle charts can be put together to show a comparison between different charts. Sounds interesting, isn't it? Now let's explore. First of all, we will import the pandas, matplotlib, and waffle library. As Waffle library is a new library for us, we have to install this library using the command prompt. So open your command prompt and type pip install waffle. You can come back to the Jupyter notebook and import Waffle as waffle. We are making a data frame so that we can understand how to use waffle charts for real scenarios. You can see how beautifully the waffle chart has plotted all the categories. You can try some variants of waffle chart by checking its official documentations. And now the next topic is maps. A map chart is used to show items on a background that is often, but not always, geographical. Maps can contain interactive shapes or display markers of different types on an image or map background. Now let's get started. So first of all, let's import Plotly Express and import the car share dataset that we are going to use for visualizing the map based on latitude and longitude of the places. You can see that the car share dataset has 4 columns, namely car hours, peak hours, latitude and longitude. So let's use the scatter map box function to plot this data. We have to specify the latitude column, longitude column, color column and size column, and then maximum size, zoom size and map box options to plot the map. We can see that the map looks beautiful. We can zoom the map, we can interact with the map and lots more. Well, that was great fun. Now let's try to plot a world map. For that, we will use the Gapminder data set, which we are already familiar with. So let's get started. In this case, we have to specify the ISO alpha column for the locations column. So let's have different colors for different continents, and the size of the points be the population of the countries. And at last, the projection that we want to use. So in this case, we are using the natural Earth projection, but there are so many cool projections out there. We have discussed the advanced visualizations, and now we'll be discussing the animated visualizations. So our first animated visualization is animation with Bubleplot. Now understand what are bubble plots. A bubble chart is a type of scatter chart which displays more than 3 dimensions of data. It provides us with the size dimension, color dimension, time dimension, bubble dimension, etc. for deep analysis. For this, we will require the Bubleplot function, and it's available in the Bubble library. As Bubbly is a new library, let's install it. Open your command prompt and type pip install Bubbly. You can see it's successfully installed. Now you can come back to the Jupyter notebook and import the Bubleplot from the Bubbly package. Now let's also import the dataset that we are going to use for implementing the Bubleplot. We are going to use the Gapminder dataset. In the Bubleplot function, we have to specify GDP per capita to Y column, life expectancy to X column, continent to bubble column, year to time column, population to size column, and continent again to color column. And after that, we can specify the title required for the chart. And as you know, the GDPs for some countries will be very high. So we have to transform our y-axis to log scale. Also, the population of some countries can be really huge. So we are specifying the maximum scale of the bubble as 5. And at last, the height of the chart as 650 units. It's done. Now you can see 2 buttons, play and pause. Let's play with the play and pause buttons. That's so satisfying. The way these points are moving with respect to different years is amazing to see, isn't it? Well, you can play with other features of Bubleplot also and try it out with some other datasets also. All right, on to our next topic, which is animated visualizations with facets. Let's get started. As we already know about facets and animated visualizations, let's start with importing Plotly Express and then importing the Gapminder dataset. First of all, let's make the same plot using the Plotly Express that we created in the previous lesson using Bubbly. Now, let's click on the play button and analyze the insights. Let's play again. Let's do it one more time. Are you able to find any useful insights? If no, then let's add facet columns into this chart so that we can notice the animation for all of the continents separately. Now, if you click on the play button, it's much easier to analyze the insights. You must try out more scenarios like this because data visualizations play a vital role in decision making. Hence, data visualization is an important skill to master. So coming to the next topic, animation with scatter maps. First, import the Plotly Express library and Gapminder dataset and plot a world map where continent is specified as color parameter, population as size parameter, and year as time parameter. This time parameter or animation frame helps us to transform a simple map into an animated map. Now you can see that we have play and pause buttons. If you notice the chart closely, then you'll be able to find out that the bubbles are growing slowly. That means from the 1950s to 2010, the population is continuously growing in almost all the countries of the world. But the major change can be seen in the United States, India, and China. And now we are going to discuss about the animation with Chloropleth Maps. First, import the Plotly Express library and Gapminder dataset. This time, the only difference is that we are going to use a Chloropleth map. A Chloropleth map is a type of thematic map in which areas are shaded or patterned in proportion to a statistical variable that represents an aggregate summary of a geographic characteristic within each area, such as population density or per capita income. Now, let's plot an animated Chloropleth map. Continent is specified as color parameter, population as size parameter, and year as animation frame parameter. From the map, you can see that we have an amazing Chloropleth map where each country is colored based on their life expectancy values. For more understanding, we can refer to the color scale given beside the Chloropleth map. Finally, let's play with the play and pause button. And this time, it's obviously more easily understandable. And here we are done with the animated visualizations. Now let's start with the interactive visualizations. We are going to discuss the Ipywidgets library. Let's start with the Ipywidgets library now. Ipywidgets is a Python library which helps us to perform interactive data analysis. It provides us drop-downs, sliders, buttons, radio buttons, etc. so that we can easily create interactive functions. Ipywidgets comes up with two different types of functions, that is interact and interact manual. Interact function allows us to interact with the program as soon as we execute the program. Whatever changes we make are visible in no time. Interact manual function allows us to interact with the program only when we click on the button. Whatever changes we make will be visible only when we click on the button. As we've gathered some knowledge about the Ipywidgets, let's install this library as it's a new library for us. To install Ipywidgets, open Command Prompt and type pip install Ipywidgets. Now, as you can see that the installation is successful, let's get into the Jupyter Notebook and import the Ipywidgets library and explore the interact and interact manual functions. Now let's import the iris dataset and check the first 5 rows of the dataset using the head function. Now let's also understand the working of select dtypes function. It's a special type of function used for selecting columns based on a specific data type. For example, when we specify number inside the select dtypes function, we are getting only numeric columns from the dataset. Similarly, when we specify object inside the select dtypes function, we get only categorical columns from the dataset. Now let's check the interact function. We have made a function to find the correlation between 2 columns of the dataset. We are getting the output as soon as we make the changes. But when it comes to interact manual function, we cannot see any change until we click on the button. That means whenever we have heavy functions, we'll prefer the interact function, whereas for interact function can be used for lighter function. Our next topic is interactive univariate analysis. We will use these interactive widgets to perform univariate analysis. Univariate analysis is the simplest form of analyzing data. Uni means one. So in other words, your data has only one variable. It doesn't deal with causes or relationships, unlike regression. and its major purpose is to describe. It takes data, summarizes that data, and finds pattern in the data. So let's get started. First of all, let's import Seaborn, Plotly Express, and Ipywidgets. We are going to use the Interact manual because it's more suitable for handling heavy functions. Now, let's import the Gapminder dataset that we are going to use for the interpretation. First, let's make a function to get the distribution for numerical function using the distribution plot from Seaborn library. Again, we are going to use only the Seaborn library along with Ipywidgets because Plotly Express and Ipywidgets together can be slow. Now, if you click on the button, you can see a chart which gives you the distribution for numerical columns. Let's change the column using the drop-down and click on the Run Interact button to check the distribution. Yes, it's working fine. I'm super excited to make an interactive function to check the distribution for categorical columns. So now let's play with this function also. You can see it's very easy and efficient. And now we're going to discuss interactive bivariate analysis. We'll take a step forward and learn how to perform bivariate analysis. Bivariate analysis is one of the simplest forms of quantitative analysis. It involves the analysis of two variables for the purpose of determining the empirical relationship between them. Bivariate analysis can be helpful in testing simple hypotheses of association. Let's get started. First of all, let's import Seaborn, Plotly Express, and Ipywidgets. We're going to use the Interact manual because it's more suitable for handling heavy functions. Now, let's import the Gapminder dataset that we're going to use for the interpretation. First, let's make a function to get the relationship between categorical and continuous functions using the bar plot from Seaborn library. Now, when you click on the button, you can see a chart which gives you the bar plot for categorical versus continuous variables. Similarly, you can also use other charts such as strip plots, violin plots, box plots, swarm plots, joint plots, etc. in place of bar plots. Let's change the column using the drop-down and click on Run Interact button to check the changed plot. Yes, it's working fine. Now, let's check the relationship between continuous and continuous functions using the scatter plot from Seaborn library. And we can change the values and see that it's working completely fine. Now, let's move ahead and also check how to check the relationship between two categorical variables. For that, we'll use the cross-tab function. Cross-tabulation is a method to quantitatively analyze the relationship between multiple variables. Also known as contingency tables or crosstabs, cross-tabulation groups variables to understand the correlation between different variables. It also shows how correlations change from one variable grouping to another. Now let's make an interactive function and see how it works. Let's change the columns and check whether the chart is changing or not. It's working well. And we will discuss about multivariate analysis now. Multivariate data analysis is a set of statistical models that examine patterns in multidimensional data by considering at once several data variables. It's an expansion of bivariate data analysis, which considers only two variables in its models. So let's get started. First of all, let's import Pandas, Seaborn, Plotly Express, and Ipywidgets. We are going to use the Interact manual because it's more suitable for handling heavy functions. Now, let's import the tips dataset. First of all, we will create an interactive function where we'll have 3 variables. The first variable will be categorical for x-axis. The second variable will be continuous for y-axis. And the third variable will be categorical, which will be used as a hue. Now we can click on the Run Interact button and we can try changing the values and see if the function is working well. Next, we can also add some palettes in the chart. You can see that there are 3 palettes that have been added, such as copper, magma, and reds. So that's a wrap for interactive data visualization. Our next topic is miscellaneous charts. There are various types of miscellaneous charts. Let's discuss them one by one. The first chart type is sunburst plots. Sunburst plots visualize hierarchical data spanning outwards radially from root to leaves. The sunburst sector hierarchy is determined by the entries in labels and in parents. The root starts from the center and children are added to the outer rings. Main arguments. Labels. Sets the labels of sunburst sectors. Parents. Sets the parent sectors of sunburst sectors. An empty string is used for the root node in the hierarchy. Values. Sets the values associated with sunburst sectors, determining their width. Let's get started. First of all, we'll import the Plotly Express library and import the tips dataset to interpret the sunburst charts. First, let's plot the sunburst chart to visualize the relationship between sex and smoker column in the dataset and keep the values as total bill. If you take a closer look at the chart, you can see that it follows a hierarchy, which helps us to understand the relationship within layers. Now let's take one more example for day and time with total bill values. And at last, let's try to add one more variable in the path, that is day, time, and sex. Now we can see that the sunburst chart is even bigger and it's properly following the path. The second chart type is parallel coordinate charts. In a parallel coordinate plot, each row of the data frame is represented by a polyline mark, which traverses a set of parallel axes, one for each of the dimensions. So let's get started. First of all, we'll import the Plotly Express library and import the iris dataset to interpret the parallel coordinate charts. Let's check the value counts of the species and species ID together so that we can understand which ID corresponds to which species of iris flowers. Let's make a very simple parallel coordinate chart where we will color the lines based on the species ID column. You can see how the parallel coordinate chart can show us the relationship of all the independent variables with respect to the dependent variable. Well, that's all for a parallel coordinate chart. Now, the third chart type is funnel charts. Funnel charts are often used to represent data in different stages of a business process. It's an important mechanism in business intelligence to identify potential problem areas of a process. For example, it's used to observe the revenue or loss in a sales process for each stage and displays values that are decreasing progressively. Each stage is illustrated as a percentage of the total of all values. Let's get started. First of all, we'll import the Plotly Express library and then we'll make a dummy dictionary of data so that we can plot a funnel. In the data that we created has some stages, and for each stage there is some value. So let's plot this data using the funnel function from Plotly Express and see how the visualization come up. It's really looking like a funnel where the number is getting decreased as you go down the funnel. This is actually representing a business model for an organization regarding the different steps a customer has to cross to become a customer. It's really cool. Although we could have used any other chart instead of using a funnel chart. But we are going with a funnel chart only because using a funnel chart is super easy and efficient. Now, let's add one more column called Office, where there will be 2 offices, Montreal and Toronto, in the data set that we created using the Pandas library, remember? Now, the interesting thing is that we can stack these 2 values together and we can understand which office, Montreal or Toronto, is giving more conversions to the organization. For that, we just need to add an extra variable, office, as color parameter. And it's done. You can take a closer look at the funnel chart and understand which office is performing better. So it's a wrap for funnel charts. Now the 4th chart type is Gantt charts. A Gantt chart is a type of bar chart that illustrates a project schedule named after its inventor, Henry Gantt, who designed such a chart around the years 1910 to 1915. Modern Gantt charts also show the dependency relationships between activities and current schedule status. So let's get started. First of all, we'll import the figure factory module from Plotly library. And then we'll make a dummy dictionary of data so that we can plot a Gantt chart. In the data set, we will include 3 columns: task, start, and finish. Now, using the create Gantt function, we make a Gantt chart. We can see that different tasks are being shown based on their time of start and time of ending. Apart from that, you can have some very cool date filters where we have options such as 1 week, 1 month, 6 months, year to date, 1 year, and all. Let's try these filters. Amazing! You can see how these Gantt charts are changing when we apply these date filters. Now let's add an extra column called Resources, where we will specify the status of the work, whether the work is started, completed, or incomplete. Let's specify the red color for not started, green color for complete, and yellow color for incomplete. So let's see how the Gantt chart looks this time. This time it's very interesting, as we can check the status of the tasks also. The 5th type chart is Ternary chart. Ternary charts is generally used to check relationship between 3 variables: a ternary plot, ternary graph, triangle plot, simplex plot, Gibbs triangle, or the Finetti diagram is a barycentric plot on 3 variables, which sum to a constant. It graphically depicts the ratios of the 3 variables as positions in an equilateral triangle. So let's get started. First of all, we'll import Plotly Express, and then we'll import the iris data set that we are going to use for visualizing ternary plots. Now let's first plot the ternary plot between the sepal length, sepal width, and petal length. You can see that there are 2 clusters in the ternary plot, so it's quite difficult to analyze. Now let's add colors to it by adding the species column to the color parameter in the ternary chart. And now it's visually clear. We can see all 3 species in the ternary chart clearly. The 6th chart type is tree maps. Tree maps is generally used to check portions of different values in a column. Tree map charts visualize hierarchical data using nested rectangles. Same as Sunburst, the hierarchy is defined by labels, and parents' attributes. Click on one sector to zoom in or out, which also displays a path bar in the upper left corner of your tree map. To zoom out, you can use the path bar as well. So let's get started. First of all, we will import Plotly Express, and then we will import the tips dataset for implementing tree maps. Let's first make a simple tree map with the day column and portion based on the total bill column. It seems very interesting. Let's add one more variable in the path after day column, that is time column. It looks even more informative. Now let's go a step ahead and add sex column to it. The seventh type chart is network charts. Network chart, which is generally used to check different networks in a chart. Network diagrams, also called graphs, show interconnections between a set of entities. Each entity is represented by node or vertex. Connections between nodes are represented through links or edges. Let's get started now. First of all, we'll install the Network X library. As it's new for us, we're going to use this Network X library because this library will help us to plot network charts. So to install Network X, you have to open your command prompt and type pip install networks. Now, as you can see that networks is installed successfully, you can come back to Jupyter Notebook and import networks, matplotlib, and Plotly Express. After that, we'll import the Gapminder dataset for implementing the network charts. We are going to plot a very simple network chart where we will visualize all the countries present in the world. As you have already known that there is no such chart which allows you to visualize a column with hundreds of values, but we can still do it using the network charts. So now we'll create a new column called Nation, where all the values will be country. We are doing this because it's going to be the root node for all the countries present in the world. After that, we have to set the size of the chart so that all the countries can fit in, and then specify the nodes, labels, and edges to plot the network chart. Now let's check the visualization. It's stunning. It displays all the countries in a very efficient way. So with this, we come to the end of this data visualization course. We have covered all important concepts in this course and hope you guys enjoyed it. If there are any suggestions, please go ahead and comment them as well. We will try our best to reply to each of your comments. So goodbye, and don't forget to subscribe to our channel for more information as well. So goodbye and take care.